Newton's three laws of motion provide the fundamental principles for engineering mechanics, and if we go through these laws one by one, we can see how they relate to statics. So his first law says, an object in motion stays in motion, an object at rest stays at rest, unless acted on by an outside force. Now, in statics, we're always dealing with objects that are in equilibrium. So, equilibrium means they will be at rest. They will not be moving. So we'll be focusing on an object at rest stays at rest unless acted upon by an outside force. What this means, let's say I have some object right here, and I have a couple of forces that are applied to it, say F1, say F2, and F3. I'm going to tell you that this is in equilibrium, it's not moving, and it will remain in equilibrium unless I have another force that is applied to it, say F4, and because this is applied to an object that's in equilibrium, it will no longer be in equilibrium and it will start to move. So in statics, we're trying to avoid this, or we're trying to figure out what forces we need to keep our objects in equilibrium. Newton's second law says that the acceleration of an object is directly proportional to the net force acting on it. That's the official what it says. An easier way to think about it is the sum of the force is equal to mass times acceleration. So we can boil down the second law into this equation. Now, in statics, we have a special case of this. Because we're in equilibrium, we will have no acceleration. So for us, when we're in statics, one of the most important equations that we have are the sum of our forces are equal to zero. So in statics, everything's equal to zero. We're not moving. Newton's third law says that for every action, there's an equal and opposite reaction. And this becomes really important when we're dealing with contact forces. So let's say we have, in some problems, we'll have a beam that's lying against a wall, and the beam's going to exert a force on the wall, and the wall is going to exert an equal force back on the beam. There'd be other forces that are acting in the problem, but this is the idea of equal and opposite reaction. We also will deal with this with structures. So if I have a structure, let's say a structure like this, real simple, and again, we have some forces that are on it. So let's say this is F1, let's say this is F2. We'll use Newton's third law and we'll want to figure out what our reaction forces are that we need right here. So we'll say this is By, this right here is Ay and Ax. So we need to figure out what these reaction forces are in this part of the problem in order to keep our structure in equilibrium. So Newton's laws of motion really set the principles and the baseline of how we attack problems in statics.